My name is Brian Gardner. I am incredibly excited to be here to talk to you all today. So what I would like to talk about today is testing. More specifically, I want to talk about test-friendly architecture, the things that you can do inside of your application to make testing easier. So for this talk, I had a few goals that I set out because I love outlining. So the first of which is some architecture patterns and principles that I've found in my experience help to make an app more easily testable. Now, my background is in Ruby on Rails, and if you are familiar with that at all, you know that testing, and especially test-driven development, is more of a gospel than a suggestion. So jumping over to Android around 2013 was kind of like getting a bucket of cold water dumped on you. It's like nobody really tests at all because testing is hard. I had this activity thing. I don't know what to do with it. Sorry. So I'm just going to tell you a few of the things that I've found, again, that help. Next, I'm going to talk a little bit about dependency injection. So where dependency injection can fit into these architecture patterns. Now, if there's one thing you take away from this talk, it should be this. The architecture principles you should be doing in your application regardless of anything else. If you don't use dependency injection, doesn't matter. Even if you don't test your application, still doesn't matter. Architecting your app is the main goal. Things like testing is nothing more than a byproduct. And that is why testing is last here, because it's kind of the least important. All right, so before we get started, quick pit stop. I made a little sample application for this, so I'm just going to kind of cover the main components of that application, what the screens are, what it does. It's not anything super impressive. It's basically a reminder application. So user sees a list of reminders, click on the floating action button, go to a create screen, enter in some data, click on a save button, they get sent back to the screen. My end goal for this application was to make it easy for me to write an integration test to prove that the user could go create a reminder and then see it on that screen. So I'll check out some of the dependencies for my particular object here. So first, I guess I should define dependencies. Yes, my slides will be going up after the fact, and the sample project. Now, when I say dependencies, I just mean any kind of object or data my class needs in order to do its job. So in this case, I have a list fragment who's responsible for displaying a list of reminders. So it first needs a reminder adapter just to set up my recycler view. It also needs a reminder store object, which in this case just saves things to a database. And it also has some date utils to figure out like when the reminder is happening. Now each of these dependencies also have some other dependencies. So my reminder adapter depends on a context because it's creating a view object. My reminder store is saving things to a database, so it depends on that implementation. My create screen is also kind of similar. Again, it depends on that store because I need to save the reminder once I actually create it. But I also have this view model I depend on. Now, this should kind of tell you I'm using the MVVM architecture. So my view model needs a context because it's just doing some string resource grabbing, a new reminder object, and a date formatter. All right, so now that we have kind of a general idea of the components I'm going to be working with, I am now going to jump into the principles and patterns that I use to kind of help keep things clean. I'm sure a lot of you have probably heard of a few of these things before. If you've ever taken some CS courses at university, they're probably going to be fairly self-explanatory. First of which, single responsibility principle. This might be the first thing everybody always gets taught, but I find it can be one of the easiest things not to follow. I can't tell you the amount of times I've opened up an Android project, started looking through some of the things, and it's like this thing does this, and this, and this, and this, and then you find out, hey, testing this thing is a huge pain because I have a bajillion things to test. Now, I think single responsibility principle can be summed down into a nice phrase, and that is do one thing and do it well. When you try multitasking, I know there's been a lot of studies on this, where multitasking reduces your efficiency to perform those tasks. So the same is kind of true for your components here. If your component is trying to do too many things, the chance that it is doing those things as well as it could be is going to go down. So if you find that you're doing too many things in an object, just break it out, have a smaller API for other things to depend on. Now, a benefit of having a smaller API means you get smaller tests, and smaller tests are more of a pleasure to look through because you don't have to scroll and scroll to figure out exactly all the things this object does. So single responsibility principle is my first little tidbit, so always try and break things out as much as possible. My next is to pick some kind of UI architecture. So MVC, not really that popular anymore. MVP, MVVM are the big ones. I've heard some things about Viper, but I think that's more of like iOS sort of things. Now, my goal here is not to tell you which one to pick, because there's pros and cons to all of them. I use MVVM because that's what I'm familiar with, and I am more efficient when I program that. But the point here is to pick one and stick with it. You want to make sure that you have a very clear separation of concerns for your particular object. So your models shouldn't be formatting any data to display. Your view shouldn't be trying to save any data, things like that. So here is my idea of what my app architecture kind of looks like. So again, I'm using MVVM. At the bottom, I have my models, view models, and views. So again, that separation of concerns comes into play here because my model should not be talking to my view. It should be going through my view model to get that data formatted, which then gets sent to the view to be displayed. Now, you can see also the activity and fragment up at the top. Since we are doing Android development, we do have to rely on activities to display things. Sometimes people use fragments as well. So these kind of live outside of these buckets. So one way I like to think about this is think of this kind of architecture as an orchestra. So your model is your brass section. The view models are the strings, and the views are your percussion. Now, the majority of the work that your user sees is going to come from these components. So they are doing most of the heavy lifting. Your activity and fragment, this is going to be more like the conductor of the orchestra. It just kind of gets everything set up at the beginning, makes sure the timing is right with your life cycle and things, and then just kicks everything off. So the box around the activity and fragment is smaller on purpose. Your activity and fragment should be as thin as possible. So you don't want it to have a ton of responsibilities here. You just want it to, again, set everything up and let them do their jobs. Third, I have my bias towards interfaces. And anybody who's familiar with the solid principles will know that this is the dependency inversion principle. Now, this just basically says that you should always try to depend on abstractions versus concretions. So pull out some sort of interface and instead of relying on a concrete class. This kind of gets towards the composition versus inheritance debate, so relying on what something does versus what it is. Now, inheritance is good in some cases if you rely on some bit of functionality based on what something is, but whenever you can, try and parse out those interfaces. So as an example from my little sample app, my reminder list fragment relies on that live reminder store. Now, it's relying on a concrete class here, which is pointing to a database. That's like where my persistence layer is. Now, this is unnecessarily tying these objects together. So my fragment is saying, hey, I can only use this one thing. So if I want to change this out at a later point, it's going to be a huge pain. So instead, I find an interface that I can pull out of that. Now, you might be able to tell that I already kind of had the interface before I started here because live reminder store. But so I find an interface here and have my list fragment rely on that. Now, the list fragment doesn't have to really change at all. As long as whatever object it's supplied with uses that interface, it doesn't have to care where your thing is being stored. It doesn't care if it's stored in a database, in a JSON file, or on a web server. So this is something that I have personally found, at least in Android testing, is that anytime I have been able to extract an interface from a concrete class and use that interface as my dependency instead, I've found huge benefits in testing. So if you're familiar with unit testing, you know mocking objects where you just create like an empty implementation and then control that stuff. Interfaces are perfect for this because then you have complete control over what that thing is doing, so you can more easily test your component. And last up is this concept of explicit dependencies. And what I mean here is any component should be very explicit about what it needs to do its work. Now, to show this off, I'll show the inverse of this, and that is implicit dependencies. So here, it might be hard to see in the back, but here's an example of implicit dependency creation. So I have a constructor for my create reminder view model, and it takes a context as a parameter. It sets this context, but then inside of the constructor, it's creating different dependencies. Now, this is frankly kind of bad because to the rest of the system, it seems like your view model only needs a context to do its job. But that's not right. It also needs that date formatter and reminder object. Now, the problem with this is twofold. The first is the problem when any kind of change is made to your application. Say, my date formatter, I find people in Europe don't like the way I'm formatting my dates, so I need to introduce some sort of locale to update it. So I go into my date formatter, update the constructor to take in a locale, and another metaphor for this is like when you drop a rock into a puddle, those ripples just kind of like go all the way to the outskirts. When you hit compile, all of the errors you see when you update this, those are your ripples. So our job as developers is to make those ripples as small as possible. So whenever my date formatter changes, I shouldn't have to change this class as a result of that. So instead, again, you want to be explicit about these dependencies. So your view model then will declare, hey, I not only need a context object, but I need these other things as well. So there's no more creation of objects inside of your constructors. Those need to be passed into that object. So this will help reduce your ripple effect. So if the date formatter changes at this point, this class doesn't care because it's just getting that object. It's not creating it. This also helps with your testing. In the previous example, there's no way to swap out the date formatter and reminder object. Now you can do some weird Java tricks to try and get around this. You can set these parameters as protected, put your test class in the same package, and then access them. But frankly, that's gross, and anytime you see that in a project, you should probably flag that and give it a thumbs down on GitHub or something. But doing it this other way where everything is very explicit, you have complete control over what dependencies are getting passed in, so this is going to give you a little bit of benefit in your tests as well. All right, quick recap. So these are going to be the 4 principles that I kind of hammer on for the rest of this talk. Again, single responsibility principle, do one thing, do it well. You have your UI architecture. Again, I don't care what you use, as long as you pick something and stick with it. Bias towards interfaces, try and extract those things where possible, and then be very explicit about what your class needs to do its job. So again, if you take nothing from this talk, it's this. Always do these things in your application. I don't care if you use dependency injection. I don't care if you test even though you should. Doing these things will reap benefits in that your application will improve. And what I mean by improve is your code will be cleaner. It'll be easier to understand, maintain, and extend. You'll have better decoupled components. You will have easier time passing in dependencies, and so forth. But people like dependency injection. It's kind of the new, well, not really new, but a lot of people are using it nowadays. So I'm going to kind of talk about where dependency injection fits in with all of these things. Now, the first thing I should talk about is dependency injection is itself not an architecture pattern. Dependency injection is a tool to reduce boilerplate in your application. If you talk to somebody and you're like, hey, how did you architect your application? If they say dependency injection, that's kind of scary. So just be kind of careful with your wording here. You don't technically need a dependency injection library to do dependency injection. In fact, I think that's kind of the crux of Dagger 2 is they're saying Dagger 2 basically generates the code you would write yourself. So you don't technically need it. Again, it just reduces that boilerplate. Now, I am using Dagger 2 in this particular example, but this really should work very similarly for any other kind of dependency injection if you use Juice or whatever it is. So I'm going to do a very quick recap of how Dagger kind of works. So I have my activity here. It needs two things in order to function. I need that view model and a reminder store. So again, we want these things to be passed into this object. We don't want that implicit creation. So Dagger is going to help us out with that. So Dagger has this concept of modules, which basically have factory methods to create these things. It just kind of figures out, hey, this class needs this type, this module can generate this type, and then it just kind of puts those two together. All of this occurs inside of your app component. So the component just gathers all of your modules, which can add all of the dependencies to your application. And then your object will just query the component and say, hey, I need these things, please provide them. Now, typically, your app component is going to be put into something like your application subclass. So you'll generate your Dagger component in your onCreate method. You'll declare a getter for that component. So my activity here would get my component from my application and then perform the injection. All right, so now that that quick recap is done, I'll talk about how Dagger as a tool applies to our architecture principles. Again, always use those architecture principles. I cannot hammer that enough. So first is the single responsibility principle. So how can Dagger help us to apply our single responsibility principle to our project? And well, to be honest, it doesn't really help here. Dagger does not care what your objects do. It doesn't care if this class does one thing or 1,000 things. Dagger's only job is to create that component and provide it to somebody else. However, you can apply your single responsibility principle to your dependency injection. In this case, Dagger, again, uses those modules to generate the components. And this is something that you don't want to see in any application. So if you see one module that just makes everything, I tend to call this like a junk drawer module. It's like that one drawer you have in the kitchen. You just throw everything in it, and it just kind of does its job, but it's a pain to find anything. So we can make this better just by separating out our modules. So give them a single responsibility. So say this one makes my store objects, this one makes my view models. But you don't have to stop here either. You can also say, hey, this store module is starting to get too big, so I'm going to split it out even more. As a side note, you can also apply this principle to the component object as well. So Dagger has this concept of subcomponents where you can basically break out your component. The subcomponent can rely on a specific subset of modules. So if you're finding your app component is getting a little bit too large for your application, you can always go down that road as well. But that's a little outside the scope of this talk, so I'm going to leave that as homework. Next is our UI architecture patterns. So how can Dagger help apply our UI architecture patterns? And unfortunately, again, it doesn't really help here either. Dagger doesn't care if something is a view model or a view. Dagger, again, just doesn't care. You can try to apply this to Dagger. So this module supplies models, this one supplies view models. But if you're doing your single responsibility principle, you should kind of be arriving on that yourself. So just, again, try to apply your your architecture patterns to your entire application. Your dependency injection code is just as important as the rest of your application, and it deserves as much care as the rest. Bias towards interfaces, or dependency inversion for you solid folks. Fortunately, Dagger is extremely good at this particular job. So again, in my refactor previously, my list fragment now relies on an interface. But of course, I can't do anything with an interface. I need an actual class for that. So Dagger can provide that particular object I need. So in my store module, I just need to provide a subtype of that interface. So I have a live reminder store. I return that, and to my list fragment, it is none the wiser. It just says, hey, this is something that can give me a list of reminders, so it's happy. Now, one of the other cool things about Dagger is it not only works in your production code, but you can also use it in other build flavors. So say my current live reminder store saves things to a database. Maybe I've outgrown that. I want some sort of metrics around that. So I decide, hey, in my next version of my app, I want to store things on a web server instead. So I will maybe make a dev product flavor for my application where I put in all these new features before merging them into master. And then I can make a dev version of my module. So hey, this dev version will instead return the development version of my reminder store, which sends them to the web server. Since my reminder store here implements that interface, again, the list fragment doesn't care. It just does whatever it needs to because it's depending on a behavior, not a particular object. And last up, explicit dependencies, and wouldn't you know it, Dagger is pretty much the perfect tool for the job here. So with our view model here, it used to be able to create these objects itself. So it just says, hey, I need a new date formatter, so I'll just get one for me. So once we moved out of that, we now need somebody to supply these dependencies for us. And well, that's basically what your dependency injection is for. So Dagger will just say, hey, you need these particular objects. I have these modules with these factory methods, so I will supply all of that data for you. The other nice thing about Dagger is it gives you the compile time checking to ensure that your object graph basically is correct. Now the object graph is basically, Dagger figures out what the classes are, what dependencies they need, and it makes sure that no nodes are missing in that graph. If anything is missing, Dagger will throw an exception during your compilation process so you know you need to fix something. You don't want to like run your app and say, hey, I have a crash now, so clearly something was wrong. So it just gives you a little bit of benefit there. So recap number 2. Again, your architecture patterns, very important, always use those. Dagger can help in certain cases, so using your single responsibility principle on your dependency injection code is great. It's gonna make the other developers you work with very happy when you don't have that junk drawer hanging around. But you do have to be careful with this. Now, Dagger can make it very easy to avoid obeying the single responsibility principle. Once you get it set up and you realize how easy it is to inject dependencies, you can say, hey, I can just keep adding more and more things to this class, so it's going to get a little bloated. So you just have to be very careful to stick to your architecture patterns. Dagger's a sharp tool, just don't cut yourself with it.
Are there like performance drawbacks to having like a junk drawer module as opposed to breaking them up into sub-modules?
I don't believe so. I think it should work just the same. It's just a little bit cleaner for us to understand. Again, it's not really relevant for your UI architecture. I'm going to wait for the questions toward the end. I'm running a little bit out of time, so it'll be all right. Again, not relevant for UI architecture if you are applying your single responsibility principle. It's very flexible at providing your interfaces and providing different interfaces in different build flavors. And again, it's basically exactly what it was made for providing those explicit dependencies. All right, now all the fun stuff, testing. Now this is actually going to be one of the smaller components here because you will find if you follow your architecture patterns, your tests should be very easy to set up. Now, testing is kind of a benefit. Again, you always want to apply those patterns. If you have something that's difficult to test, most likely you are not applying these principles correctly. So you want to go back and make sure, say, hey, am I being very explicit about my dependencies? Is this thing doing too many things? Am I relying on interfaces when I'm actually relying on concrete classes and so forth? So first off, I'm going to cover unit testing and how our architecture patterns and Dagger work, or dependency injection works with our unit tests. And I can kind of sum up the dependency injection part like this, and that is, do not use dependency injection in your unit tests. If you stick to your principles, it should not be necessary. Remember this stuff, being very explicit about these dependencies. This is basically the code that it's going to generate for you. You are going to have this lovely public constructor where you can pass in all of your dependencies here. So inside of your unit tests, you can just use that constructor to generate that object. In this case, I'm using Mockito to generate mock objects so I can control what those things are doing. But again, Dagger is unnecessary here because setting up Dagger to provide these things would just be a lot of work for no benefit because it's so easy to do itself. Integration testing is a little bit trickier. You want integration tests to be as close to real as possible. So in my case, I wanted to test that I could add the reminder on the create screen, go back and see it in my list. There are a few exceptions to that case. One, you probably don't want to hit the network on your integration test. A couple of tests, it might be fine. You just have to accept that they're going to be a little flaky. If your device drops off the network, your test is going to fail for a reason you don't expect. If your dev server or whatever goes down, it's also going to fail. So instead, you can provide fake versions of those components. So in my case, I wanted to use a fake version of my reminder store because I didn't want to have to deal with cleaning up a database because that can be kind of painful. And also the writing to the database is going to be very slow, and I want my tests to be a little faster. So in integration tests, you typically don't want to supply a mock object because if you start adding too many mock objects, you're not really testing your application, you're testing your assumptions about how the application works. So instead, I'll use a fake here. And a fake is a real object that actually does things and has side effects. It's just supposed to be a very pared down version of your object. So my fake reminder store, I'm just storing all of my stuff in memory as opposed to the database. So it's faster and it's easier for me to clean up afterwards. This also comes from our bias towards interfaces thing. Since I have this interface, I can actually create a fake version to supply it. But of course, when I have this fake version, I need to use my dependency injection to supply it to my objects. So I'll have to create a fake module that generates that for me. I'll have to have a test version of my component. Again, most of your functionality should be the same as your production, so most of your modules should be your production modules. In this case, I only had a single fake module to supply the one fake object I needed. Next, I need to have a test application, so I can say, hey, generate this component for me when my activity starts, and then I can actually access that. But with Espresso, you do need to do a little bit more work to use this test application. You have to have a custom test runner. Now, the Android JUnit runner is the default, so you just extend that. You're going to override the new application method. You can basically just generate it for you. Most of that isn't important. The only thing you need to do here is pass in your test application as the second parameter. Once you have your test runner, you set it up inside of your app module build.gradle. So you say, hey, use my test runner here, and then anytime you run your integration test, it will use your custom test runner, which will use your custom application, which will generate your test dependency injection component. So setting up your integration test should look basically the same as they did before. There's nothing really special going on here. So you use the Android JUnit runner to run your test. You use your activity test rule to tell it what activity to set up. But in this case, I am injecting my reminder store into my test here just so I can clean it out after each test run. And you can see the actual code here for triggering that injection. I'm using my test application to get my component and then calling the inject to actually set that value for me. Now, there is one small issue with this, and that is mostly kind of my fault. I do like to use the Canary versions of Android Studio, so I am using 3.0 Canary 5, and implementing the custom test runner doesn't exactly work right now in Android Studio. This is terribly hard to read, but you'll basically run it and it says, hey, I can't find instrumentation for your test runner, and it says, hey, you have an empty test suite. I don't know if there's a way to get around this for now, so basically you can just run your tests from the command line instead. Say, hey, GradleW connected Android test. Everything works just fine that way. So hopefully that'll get fixed before they push it out to beta. And for those of you who use RoboElectric, I'm sure some of you had questions after I kind of skipped over that for integration tests. RoboElectric is, I kind of think of them more as an integration test because you have these activities and fragments and things that are very connected to the Android system. But RoboElectric is going to be similar to your Espresso test. You're going to want to make a test component, provide it with mock objects so you can easily control what is happening. But again, if you are following the architecture principles here, your activities should be very thin. Again, think conductor in the orchestra. It's only responsible for setting things up and then watching them go. So you shouldn't really have a ton of things to test in your roboelectric tests. But again, it's very similar to Espresso. You'll have a fake object, a fake module, test component, test application. You just don't need the custom test runner. You just say, hey, use this application in the @config line. All right, so I am almost out of time here, so my quick conclusion. Use the architecture patterns. I don't care, again, if you're testing or not. Those architecture patterns are the end goal of your application. You want highly decoupled components, you're leaning on interfaces, you are very explicit about your dependencies. Your dependency injection just kind of helps you along with those things. So creating the objects you need at a particular time and providing them to you, and then easy testing is just a benefit here. If you're doing everything else correctly, your test writing should be easy. If your test writing isn't easy, that points to problems with your architecture, so you want to go back to those architecture patterns and try and figure out what you can improve there. All right, so my last little who is this guy slide. My name is Brian Gardner. Again, I work for a company called Big Nerd Ranch. You may have heard of us from our Android books that we write, classes we teach. We also do things like consulting work, so a lot of the stuff from this talk is just things I've picked up here and there from doing consulting work. We are actually sponsoring the conference here, so come check out the table. We got stickers, because I know everybody loves stickers. We're also doing some book giveaways, so if you want to win one of those, if you're a newer Android developer, come check us out. We'd love to talk. So yeah, I think 5 minutes left, so if anybody has any questions, I'd be happy to take those. You can kind of verify that your modules are working correctly because of the compile time checking, at least that Dagger does. So when you build out your fake module, you're guaranteed it supplies the right type of dependencies, because if it doesn't, you're going to get a compile time error. Dagger will say, hey, this thing needs this class, but you don't have a module that supplies that. As for the same type of functionality, that's where you're going to try and lean on that interface finding. So pull an interface out for a particular thing. So when you create a fake version, you'll just implement that interface. So it guarantees that even though it doesn't function the same as your real object, it has the same kind of behavior, which is the important part. In my experience, most of the problems have come from like not using singletons where required. So you say, hey, I actually, silly, I did this, but I ran into that error in my own application. I was like building out my component. I'm like, all right, I need my store object here, so I supplied that. And then I was going back and forth. I'm like, hey, my thing's not showing up on the reminder list after I create it. What's happening? And that's just because I messed up and didn't declare it as a singleton. I haven't seen too many issues of null pointer exceptions. Usually if you have any kind of very complex logic inside of your module class for like figuring out what to supply, that is kind of a code smell, I think. So you might want to break that out into multiple provides methods. Dagger has this cool thing, the @named annotation. So if you need different objects of the same type, you can say, hey, this is this kind of object, this is this kind of object, and then you just specify what kind you want in the constructor. Not off the top of my head, but I believe I read an article recently about that. So after my talk, I'm going to try and post, well, not directly after the talk, but by the end of the conference, I'll try and post some stuff up on Twitter. I'm going to post my slides, hopefully the application I use, and then some like conference talks and blogs and stuff that I've read about it. But mostly for ViewModel, I know one of the things I always try to do with view models is I try to keep the Android components out of my view models as much as I can. Because if you can do that, then you can just run them with normal JUnit. You don't have to do anything special. In my case, I did have to have a component object there because I needed some string resources. You could try to get away from that by, instead of relying on the context, by passing in the string that you wanted there. But if you start getting into injecting strings like that, that's going to be really gross. I feel like you're going to have like a string resources module, and I would not want to see that on any Android project I ever work on. So keep out your Android components, but if you can't, like I did before, just mock out those things in your unit tests, and then just be very explicit with what they should be returning. All right. Well, if there aren't any more questions, thank you so much for being here. Big thank you to the people who put on the conference, all of the organizers and everything like that. But thank you, and I can already tell this is going to be a fantastic conference. Thank you so much.